Hello, my name is Łukasz Kulas. I'm from Gdańsk University of Technology, Poland. In this presentation, I would like to show you one of our highlights we developed within InSect project. I would like to show you how you can increase situational awareness of a ship or a vehicle using our scalable and reconfigurable payload. Our motivation comes from Gdynia Maritime Authority in Poland, and such a vessel as Tucana visible in the center needs situational awareness system to better understand what is happening in environment around the ship. Then the crew can better maneuver and increase safety and efficiency of their operations. We developed a system that will be capable to put all the objects around in a nice 3D visualization that will be capable to detect objects in close proximity of the vessel of different size. And also we would like that system, and actually it was one of the requirements, that we should determine the position of the object that is relative to the vessel itself, and also mark this position on the map. We started to develop solution that is very scalable and flexible, because you never know how big your ship or boat will be at the end. Here it is a short movie showing how situational awareness can look like when you install radar sensors, LiDAR sensors, and visual cameras in different positions. You can see that our vessel will be capable of detecting a ship or also an object, and in the future it will also support the crew to mitigate the threat and reroute. Our key system parameters are as follows. The maximum range is approximately 300 to 500 meters. The angular width of detection field is 70 degrees. The system can work in real time, providing full detection performance also at night. It's very quick to install and is able to detect objects greater than half a meter in any axis, even those floating on the water. In our system, we are able to map the whole environment in 3D and put it on the map. And also we tested this system at sea state 3. In this slide, you can see some vessel types our system was tested on, from small leisure boats to Tucana boat, which is bigger in size, and to our autonomous boat we are developing at Gdańsk University of Technology. The system components are the main unit and battery set, and to this main unit you can connect up to 4 sensor boxes. In each sensor box you can install LiDAR, radar camera or infrared camera. The whole system is very compact. It can be flexibly placed on your vessel, and it is also supported with very accurate GNSS receiver. One of the key aspects of the system is its modularity and scalability. Thanks to the interfaces we used, you can install the system on a small vessel, but if a vessel is bigger, you can also install more sensor boxes to cover the whole 360-degree area. But then, if you need even more boxes, you can install a new main unit. Here you can see an exemplary visualization of payload data. We installed this system on real boat, and we recorded cameras and also LiDAR and GNSS data So here you can see how the system operates in real conditions. Now you can see that there is a live buoy, barely visible on camera view, but perfectly visible on LiDAR view. So as the boat progresses, the live buoy is more and more visible on cameras, but it has very high contrast when you look at LiDAR data. The same it is if we consider buoy at the entrance of the port. It's a small object, barely visible with a naked eye, but visible in LiDAR data. Here are detection examples in configuration installed on a bigger boat. So the system was installed at one of the boats owned by Gdynia Maritime Authority in Poland, and we were able to detect different objects and place those objects on the map, so the boat skipper knows where the object is placed. We can also detect and do ranging. So for example, here you see the distance to the object detected by our system. You can also detect a live buoy that is barely visible in the camera view. Additionally, the system is capable of spotting small objects like a marking for fishing nets, which are extremely dangerous if you do not spot them on time. The system is resistant to waves. It means that when you will see the system view, you will not see the clutter because it is filtered. So here on the right-hand side picture, you will see red clutter and detected yellow object that is also visible on the camera view. One of the possible applications is support in mooring process. If you have a big vessel or boat, mooring is extremely difficult because you have to watch out for many objects that are present in port. And here, using our situational awareness system, you will see all the objects, and also the system will allow you to park your boat as you can do with modern cars. The system can be also used for 3D mapping. Here you can see our autonomous boat going next to port infrastructure, and then by recording visual and LiDAR data, we were able to automatically develop 3D models, and those models can be stored and compared by specialists to detect some anomalies. So for example, one will understand that part of the infrastructure should be repaired. Finally, we also use this awareness system to increase capabilities of our autonomous all-terrain vehicle. Here you can see all-terrain vehicle in a mission around one of our faculty buildings, and then you can also see that the robot can understand, can detect different objects, classify them, and also report if there are any anomalies, like a human in a restricted area. If you think our reconfigurable payload can be used in your use case, either by installing as a part of infrastructure, either by installing on your vehicle, please contact me. We would be very glad to support you and to support your use cases. Thank you.